In this bar chart, you can see that x-axis shows the participants involved and the y-axis shows the resting heart rate levels. This bar chart shows you that participant 10 has a high resting heart rate of about 92. This could suggest he has tachycardia. Whereas participant 4 has a very low resting heart rate of 55, suggesting that he is very healthy and fit. Bar charts are good at summarizing large sets of data and classifying trends. They give good overall pictures of data, allowing estimate values to be made quickly. They also allow a visual check of the data, making it easy to pick out any mistakes or anomalies. Box and whiskers. A box and whisker plot or box plot is a convenient way of visually displaying the data distributed through their quantiles. The lines extending parallel from the boxes are known as the whiskers, which are used to indicate variability outside the upper and lower quartiles. Outliers are sometimes plotted as individual dots that are in line with whiskers. Box plots can be drawn either vertically or horizontally. On this graph, you can see that the systolic blood pressure for all the participants was much higher than the diastolic blood pressure. Histogram. A histogram visualizes the distribution of data over a continuous interval or certain time period. Each bar in a histogram represents the tabulate frequency of each interval. Histograms help give an estimate as to where values are concentrated, what the extremes are, and whether there are any gaps or unusual values. They are also useful for giving a rough view of the probability distribution. This histogram shows thigh girth of the participants. Normal distribution curve. While standard deviation focuses on the bulk distribution update around the mean, normal distribution analysis analyzes the location, the majority of the data. The location can indicate whether there is an equal grouping around the mean or whether there is an unequal alignment either side. If the majority of the data is located to the right of the mean, this indicates that there is a negative skew, whereas if bunched to the left, this is known as a positive skew. Normal distribution described as a bell shape when plotted on a graph. In an exact, the normal distribution, the mean, median, and mode are all the same. If the distribution is asymmetrical, this is not normally distributed. In a normal distribution, 68% of the data should fall within one standard deviation from the mean, referred to as plus or minus one standard deviation. 95% of the data will fall within plus or minus 2 standard deviation from the mean, and 99% will fall within plus or minus 3 standard deviation. Most data that we collect we would expect to be normally distributed. Therefore, we would always want 68% of our data to forward in one. If the results were normally distribution curve, then we would use parametric testing. Asymmetrical distribution curve. If the results were disfigured, then we would be using a non-parametric test. If there are outliers, then you would use 2 ways to avoid their effects on the data. The first is trimming, which is removing the 2 outliers from the data presentation. The second is windowing, which is when you change the outlier to match the closest true figure. Outliers. Outliers are plots or pieces of the data that are not in the line or matching the rest of the data which is collected. If there are outliers, then you would use 2 ways in rid of them, which is trimming, which is removing 2 outliers, and there is windowing, which is when you change the outliers to match the figure closest true figure. Quantitative data analysis, part 3. Descriptive statistics. Descriptive statistics is describing the findings in numerical form at a basic level. It measures central tendency and measures of the variability or dispersion. This measures the central tendency, including the mean, the mode, and the median. The measures of variability include the standard deviation, variance, minimal and maximal variables, and any skew in the data. Measures of central tendency. Measures of central tendency include the mean, median, mode for a range of data. The data display shows the standing vertical jump for the gymnast. The mode, which is the most common value, is 43. The median is found by ordering the data and finding the middle value. The median here is 42. The mean is calculated by adding up all the numbers and dividing them by the number of participants. The mean in this example is 37.2. Range. The range is the difference from the highest value and the smallest value. When analyzing the range of data, we are identifying between the highest and lowest value. Using the original data, you can see that the lowest measurement was 15 centimeters and the highest was 56 centimeters. The difference between the 2 values is 41 centimeters. This is the range. Interquartile range. The interquartile range is the measure of variability based on dividing a data set into quartiles. Quartiles divide a rank-ordered data set into 4 equal parts. The middle value is the median, and the values either side of the median are divided into 2, making 4 quartiles. The interquartile range shows the range in values of the central 50% of the data. To find the interquartile range, subtract the value of the lowest quartile, or 20%, from the value of the upper quartile, or 75%. In the example on the slide, the standing vertical jump can be ordered, and the lowest quartile is 21.5, which then subtracted from 49.25 gives an interquartile range of 27.75 centimeters. Standard deviation. The standard deviation measures the variation of data from the mean value. Using this method, you are attempting to identify how much data is dispersed each side of the mean. It can be calculated by the square root of the mean of the square root of all deviations away from the mean. We would record this calculation as a value plus or minus around the mean plus standard deviation. For example, if we had a small group and we weighed each individual, we may find that the average weight is 70 kg. By carrying out our standard deviation calculations, we may identify that the variation of data is 2.5 kg, each side of the mean. To record this, we would show our data as 70 plus 2.5 kg, which represents the mean value and the data spread around it. This is different to the range, as the range considers all the data and provides us with the lowest to highest value. Standard deviation focuses primarily on the majority of the data, which is located around the average. Quantitative Data Analysis Technique Part 4. Inferential Statistics. Inferential statistics allows you to make inferences about the population from the sampled data. Inferential statistics are valuable when examination of each member of an entire population is not convenient or possible. In hypothesis testing, main aim is usually to reject the null hypothesis. Hypothesis testing is an inferential procedure that uses sample data to evaluate the credibility of the hypothesis about a population. A null hypothesis states that the independent variables being studied makes no difference to the end results. Decision tree. The decision tree helps the researcher to determine the best test to use to analyze the research data. Spearman's rank correlation.